In this lecture, we will concentrate on ozonolysis reaction only. R1, R2, R3, R4, these four groups may be alkyl groups or hydrogen. So, we are performing ozonolysis reaction on alkene. First, it will form the alkene ozonoid, and then upon applying ZnH2O or DMS, it will give aldehyde or ketone depending upon the nature of R. Now let us come to the mechanism. While performing the mechanism, we will ignore this alkyl or hydrogen to make our life simple. We will show only the bonds and focus on the part where the ozonolysis will occur. Now, a double bond gets attacked by ozone. How ozone looks like? This is dioxygen and O3 is there is a coordinate covalent bond between the dioxygen and an oxygen atom. So this is the structure of ozone. Now, since this bond undergoes a heterolytic fission here and it converts to a pi bond in this position, here we get a carbocation and we get O minus here and one carbonyl is released. So this bond is absent. This bond is absent and we have a pi bond here, so we have the carbonyl compound. Now let us flip this carbonyl. So this reaction path will give us the alkene ozonide. C bond O bond O, pi bond will open up, a sigma bond will form, and we have a peroxo bond here. So we get alkene ozonide. Now we will treat this compound with H2O. H2O will undergo nucleophilic addition so we will get one carbonyl product is obtained. This sigma bond will break, so it will be isolated from this ozonide. We have a pi bond here, so we will get the one carbonyl product. Now what happens to the other part? We have this H2O to be connected and we have this peroxide ion. Now this will extract this H plus. Since this unit is released, we will have a negative charge here. This will form a pi bond and there will be plus. Now this will extract this proton to neutralize this species. So we will end up with H2O2, H bond O bond H, and the other carbonyl product. So this is one product, this one, and this is one product, this one. Now this H2O2 will be neutralized by zinc to form ZnO and H2O, so that it will not be able to oxidize any aldehyde if produced during the ozonolysis process. So what happens? This double bond breaks open and we get two fragments. Both are carbonyl compounds. If these are all alkyl groups, we will have ketone, and if there is one hydrogen, we will have aldehyde other than formaldehyde, and if we have both these R to be hydrogen, we will get formaldehyde. A problem is given. A Roman 1 O3 excess, Roman 2 ZnH2O. Now, the products that are obtained is supplied, and those are 1 mole ethanol plus 1 mole glyoxal plus 1 mole acetone for 1 mole of the reactant. We have to find A. Now this is a retrosynthesis, since we are starting from product and we will predict the reactant. So this is acetone, this is glyoxal, means ethan 1,2-di-L, and this is ethanol. Now we are writing this in this pattern because upon ozonolysis a C double bond C ends up with 2 carbonyl groups. So this is the possibility that A will look like this structure but will be devoid of these oxygens and it will be replaced by a double bond here. This is our prediction. Now if we go back, that is we apply zinc water here so that we get this set of products. So before applying this, what was the ozonide form? It was like here we have one CH3 and one H, and this is the ozonide. Now we have one hydrogen here, another hydrogen here, another ozonide which gets converted to carbonyl later on. We have 2 methyl here. Now upon analyzing the products, we will be able to find the position of unsaturation, that is position of double bond, and number of such unsaturations depending upon the number of ozone molecules it takes up. So the actual molecule with which we have started, that is A, this is CH3CH, CH3CH. Here was the double bond. It is CH bond CH, again a double bond. Now one CH3 here, and we have to write CH3 here. So this is the starting compound A. So number of unsaturation is 2 and the positions are this. So this can be named as, it is 1, 2, 3, 4, 5, 6. Hexane, now there are double bonds, so it will be hexene, 2 double bonds, so hexdiene. Now the positions 1, 2, 3, 4. So hex 2, 4 diene, and here it will be 2 methyl. So we can identify, we can predict the starting compound, whether it is saturated or unsaturated, we can predict it. Actually, if it is unsaturated, then only it will react. If it is saturated, it will not react with ozone. Now, position of unsaturation can be determined and the number of unsaturation can be determined. So, this is the importance of ozonolysis reaction. In another problem, ozone is given in excess to 1 mole of B, and ZnH2O or DMS is applied later on. And it is found that glyoxal is the only product and it is in 3 moles. So we have 3 moles of glyoxal only. Now what is the structure of B? This is our quest. If we write in this manner to start the retrosynthesis like the previous problem, we will end up with the product which will be aldehyde. And 2 moles of ozone will be consumed, since we will have 1 double bond here and 1 double bond here. Now if this compound has 2 aldehyde groups, it must be reactive. But the compound is found to remain unreacted in many cases and is found to be stable. Also, the aliphatic nature is absent in this compound. How many moles of ozone is consumed actually? And upon giving a definite amount of excess O3, when we study the amount of O3 that is left, it was found that 3 moles of ozone is consumed by 1 mole of the starting compound. So, in this format, if we write, we will be able to consume only 2 moles of ozone, 1 here and 1 here. So you have to write in such a way that 3 moles of ozone must be consumed. So we have to bring these 2 groups in vicinity. The only way to put this is to make a cyclic pattern. So we first write the basic structure. Now here we place this double bond O, double bond O, this is 1 molecule of glyoxal, this is also, this is also. Now this was obtained when we treat ozonide with ZnH2O or DMS. So what was the previous structure? This C double bond O and C double bond O was actually the ozonide, and before the application of ozone it was a double bond. So we write here the ozonide first. This was obtained upon applying 3 moles of ozone. We have C single bond C here, C single bond C here, C single bond C here. Now ozone must have attacked the double bonds only. We have ozonide here, so actually there was a double bond here. There was a double bond here. Here was a double bond. So this is benzene. So the starting compound here B is benzene. So in this way we can determine or predict the structure of any substance with the help of ozonolysis reaction. Now there will be a homework for you solve it in a paper, take a clear image, upload it in your drive, and then post the link, keeping link sharing option turned on in the comment section. So we are taking orthoxylene as the reactant. This is orthoxylene. Now we are applying ozone here, not limited amount. Whatever amount is required is given. Then the ozonite formed is treated with ZnH2O or DMS. You have to find the number of products and you have to name them. Which products are obtained and in what ratio. So this is your homework.